Python, a high-level language for everyone. Agenda, programming language paradigms, Python history, why Python, Python execution lifecycle. Getting started, basic workflow, run, install, and test. Programming languages. A programming language gives you a precise, unambiguous way to describe a sequence of computations to a machine. If you make a mistake, most languages catch it early at a syntax check or compile step before real damage is done. Almost every piece of modern software is written in some general purpose programming language. Any team building software relies on a language whose ecosystem fits the problem. Solving every problem in raw machine code by hand doesn't scale. Interpreted and compiled languages. A compiled language translates source code into machine code ahead of time, producing a standalone binary. An interpreted language like Python reads and executes source code line by line at runtime. Compiled C, C++, Go, Rust. Interpreted Python, Ruby, JavaScript. Problems without a high level language. Single point of failure. A misplaced pointer or memory bug can crash the whole program. Manual memory management is tedious and a common source of serious bugs. Verbose boilerplate is needed just to read a file or make an HTTP request. Slower to prototype ideas since every change needs a full compile step. Harder to onboard new engineers into a dense, low-level codebase. Misses out on the huge library ecosystem that high-level languages provide. Python language system source code is written in plain.py text files and kept in a source or Git repository. The CPython interpreter compiles source to bytecode, then executes that bytecode on a virtual machine. Packages are installed from a remote registry, the Python package index py. Other similar high-level languages, Ruby, JavaScript, Go. Python advantages. Reads almost like plain English, which shortens the learning curve for new developers. Speeds up development with a huge standard library and even bigger third-party ecosystem. Runs the same way on Linux, macOS, and Windows without recompiling. Makes prototyping and scripting fast thanks to dynamic typing and an interactive read, evaluate, print loop REPL. Strong support for data science, machine learning, web development, and automation. Integrates well with C extensions when raw performance is needed. Everything is an object almost. One huge benefit is that in Python, almost everything numbers, functions, classes is an object. Functions can be passed around, stored in variables, and returned from other functions. Dynamic typing means a variable's type is checked at runtime, not locked in ahead of time. Automatic garbage collection frees you from manually tracking memory allocations. A single interpreter session lets you inspect, test, and modify running code interactively. Variables and functions. Variables bind a name to a value without declaring its type ahead of time. Functions package logic behind a name that can be called with different inputs. App.py. A typical script imports what it needs, defines behavior, and runs it under a main guard. Classes and dictionaries. Here, a small class models a user backed by a dictionary of stored records. History, created by Guido van Rossum, first released in 1991 as a successor to the ABC language, named after the British comedy show Monty Python's Flying Circus, not the snake. Python 2 and Python 3 coexisted for over a decade. Python 2 reached end of life in 2020. The Python Software Foundation now stewards the language's development and community. Consistently ranks among the most widely used programming languages in the world today. Why Python? Readability, clean, indentation based syntax that's easy to learn and maintain. Battery is included. A rich standard library covers most everyday tasks. Massive ecosystem. PyPy hosts hundreds of thousands of third-party packages. Versatile. Used for web apps, data science, automation, and scripting alike. Strong community, extensive documentation, tutorials, and support. Free and open source. Governed by the Python Software Foundation. The Python interpreter. Python 3 is the interpreter that reads, compiles, and runs every .py file you write, compiles source to bytecode, and caches it in PyCache for faster reloads. A virtual environment gives each project its own isolated interpreter and packages. Never mix system-wide and project packages. Always work inside a virtual environment. Python execution lifecycle. Edit.py file, write, syntax check, parse, compile to .pyc bytecode, Python 3 app.py execute. Source is written, parsed for syntax errors, compiled to bytecode, and finally executed by the interpreter's virtual machine. Getting started with Python. This leads us to the three commands that get a project off the ground. Python 3 minus minus version. Check that the interpreter is installed and see its version. Python 3 minus m pnv dot penv. Create a project local virtual environment. Pip install package. Add a third-party package to the environment. Basic workflow. Author a Python file code correlated to domains like networking, finance, enterprise calculators, media, maintain and optimize. Running, installing, and testing. Some call run, install, and test Python's everyday loop. Fast to iterate, no compile step between edit and running the code. pip installer adds a package in seconds straight from PyPy. Virtual environments keep each project's dependencies isolated. PyTest and similar tools make automated testing straightforward. Supports many workflows, scripts, web apps, data pipelines, notebooks. Works the same across every OS that ships a Python interpreter. Any questions? Thank you.